So far we've looked at qualitative measures of solution concentration, and by qualitative I mean that there's really no numbers here at all. So there's no 1.7 or 3.8, it's just sort of a qualitative, just a word. So unsaturated means more can dissolve, so more solute can dissolve in the given amount of solvent. So imagine you have a glass of water and you sprinkle a little bit of salt in it, that is unsaturated, and of course you can sprinkle a little more salt in it, it'll dissolve, it's still unsaturated, and eventually you'll just sprinkle enough salt in there that no more can dissolve. That is a saturated solution. And how do you know you've got a saturated solution? And the answer is you just keep adding more and more solute, and eventually the solute that can't dissolve will just crash down and fall to the bottom of the solution. I suppose saturated is pretty quantitative. There's only a certain amount of solute that can dissolve. So in 100 grams of water at room temperature, 36 grams of salt, sodium chloride, can dissolve. That's saturated. And if we heat that water up though, some of that extra solute will dissolve. And if we cool it back down again and keep everything nice and clean, some of that extra stuff will stay in there, and that's our saturated solution. I'm sorry, our supersaturated solution. But these are all pretty qualitative. So if you went to the physician's office and you said, hey, how's my cholesterol doing? And they said, gosh, it's actually a little bit high. The very first thing you might want to say is, well, how high is it? We want numbers. We want quantitative measures. We want to know, is it 1% high or 10% high, or are we at like 3,000% cholesterol, in which case we might possibly be dead. So this gives us quantitative measures, so we have to actually have numbers. And in chemistry, the solution term that we use more often than not is what we call molar concentration, or molar conc, and sometimes we call this molarity. And this is a quantitative measure of solution concentration, and we define it as follows. So molar concentration is the number of moles of solute, so that's the thing we're dissolving, divided by the number of liters, or the volume in liters, of the whole solution. So we can get a number out of this. So for example, if we had some salt and we dissolved, say, 0.25 moles of salt, so that's sodium chloride, in water. So that would be an example of an aqueous solution, and the total volume was, say, 0.50 liters. Then the molar concentration, or the molarity of the salt, would be 0.25 moles. So that's the amount of solute divided by the amount of solution, 0.5, and we can see that that will actually be 1/2, or if you prefer 0.50. And the units, we can write moles per liter, and sometimes it's a good idea to write down the solute next to it. So it's 0.5 moles per liter of sodium chloride. So I think we're ready to kick it up a notch here. So we can talk about another molarity example. We can look at an abbreviation to avoid writing all these long symbols out. And here's the problem. So what's the molarity? So what's the molar concentration of 12.5 grams of sodium chloride dissolved in water with a total volume of 250 mils? Presumably the water is the solvent. The sodium chloride is the solute. And so we can take our definition of molarity. So molarity is the number of moles of solute, so that would be the number of moles of sodium chloride divided by the number of liters of the whole solution. And here's the problem here, because right now we don't have either one of these, do we? The number of moles of solute, that's the sodium chloride. We don't have the number of moles, but we do have the number of grams, and we can convert grams into moles. The number of liters of solution, well, we have the number of milliliters. So we've got a couple of things to do here, and we can do them in any order, but I think probably the milliliters is the easy way to start. We know that the 250 milliliters, so the decimal point at the end, is telling us that that last figure there, that last zero, is actually significant. Remember, zeros to the end are significant if there's a decimal point. How do we convert that into liters? There are 1,000 milliliters exactly in a liter. That's an exact conversion, and we can see that dividing by 1,000 is just the same as moving the decimal place 3 over, so 0.250 liters. And that, if we're paying attention, has 3 significant figures. So the next thing we need to do is to figure the number of moles of sodium chloride. The number of moles of sodium chloride we can figure out by calculating the formula mass, the molar mass if you like. We have 1 sodium, we have 1 chlorine. If we look these up on the periodic table, sodium is 22.99, chlorine is 35.45, and so if we sum these together, we will get the molar mass, which I get to be 58.44 grams per mole. So we can convert our 12.5 grams of sodium chloride using this molar mass. We've got the number of grams in a mole, so the number of grams has to go on the bottom because that's the only way for it to cancel out, and the number of moles is going to go on the top because that's what we'll end up with. We can go ahead and red line those out, so that looks good. We now get the number of moles of sodium chloride, and if we go ahead and we take that to, let's see, that has 3 sig figs, that is exact, and this has 4 sig figs. So our final answer is actually going to be good to 3 significant figures. And if we go ahead and type that in on our calculator, we get 0. So the 0 doesn't count as significant. 2, 1. The next digit that's showing on my calculator is a 3, but the digit next to it that I'm going to round off is an 8. And because I'm rounding off an 8, that means that 3 gets rounded up to a 4. And we should probably put those units in. So that is moles of sodium chloride. That gives us enough information now to find the molar concentration. Our molar concentration, we can just flip back up to the top, is the number of moles of sodium chloride over the number of liters. We have 0.214 moles of sodium chloride. I'm going to write that sodium chloride in. The number of liters was, well, 250 milliliters. That's 0.250 liter. And we can push this on our calculator. And my calculator says this is 0.856. And what are the units? The units are moles of sodium chloride. I'm running out of room here, per liter. So we can go ahead and write that down, 0.856 moles per liter. So how do we abbreviate this? So we said the molar concentration of sodium chloride is 0.856 moles per liter of sodium chloride. There's a couple of abbreviations we can use here. One is that left-hand side, the molar concentration of sodium chloride. That's kind of a mouthful. So we use square brackets as a means to say the molar concentration of whatever is inside of me. So I'm going to go ahead and write sodium chloride inside of there. And sodium chloride, that's NaCl. And those blue brackets around her are telling me that that means the molar concentration of what's inside. So what do we have on the other side? We have 0.856 moles per liter. And moles per liter we typically abbreviate using a capital M. So we could go ahead and write it as 0.856 capital M NaCl. And if you've been in our lab, if you remember our lab, then we always used solutions in the lab, and if you remember, we always wrote an M next to a number next to the identity of the solution. So in lab, when we wrote, say, 1M, we were saying that there's 1 mole per liter. That's what that capital M means of whatever comes next to it in that bottle.